All right. So on that would have been Wednesday, you guys would have done the lesson called "What is Chemistry?" And so we really just kind of like looked at the basics of what is chemistry and kind of looked at some of the really important little components that you guys probably learned in elementary school, but we kind of need to just recap. So chemistry is a study of substances of which material is, or matter, sorry, is composed of, the investigation of the properties and reactions, and the use of such reactions to form new substances. So matter is really anything that has mass and takes up space. And where we're talking about mass, I need you to know that mass and weight are two different things. So the amount of mass is basically like all the atoms and every little piece that makes up who you are or what the object is, whereas your weight it's the force of gravity on that mass. So there's two different things. So say if I were to teleport to Jupiter, my mass would stay the same on Earth and Jupiter. But if I were to weigh myself, I would have two different weights on Earth and on Jupiter. Okay. So those are two different concepts. So it's not as important right now at grade 9 level, but as you move through the grade 10, 11, 12 science courses, we do have a big discussion on, and like, mass is talked about so often. It's used in a lot of calculations. So it's just really important to know that, mass and weight are not the same thing. But anyway, so there are 4 types of matter, or states of matter. So we have solid, liquid, gas, and plasma. I could probably say 9 out of 10 of you would have known the first 3, but maybe the 4th one was a brand new one. But anyway, so plasma it's an ionized gas is essentially what it is. It's not really as commonly known in terms of our states of matter, but some common examples would be like, say, the plasma in your blood, neon lights, that gas that runs through a neon sign is all ionized gas. So that's a 4th and not as commonly known 4th state of matter. Okay, and then we talked about classifying matter. I'm hoping I should have talked about at least most of this in elementary school. And whether or not you remembered that, though, I guess is another question. But if not, hopefully this is a good recap of that. But so when we're looking at classifying matter, we can put it into two big groups. You can classify it as mixtures, or you can classify it as pure substances. So if it's a mixture, this is a combination of pure substances, not chemically combined. So you'd be looking at this little area here and say maybe you have like table salt and water. Those would be 2 different pure substances that you can mix together to make a mixture. So if you have a mixture, then you could also have a subclassification of either the heterogeneous mixture or a homogeneous mixture. So if it was heterogeneous mixture, this is where you could see the different parts in the mixture. And so hetero means different. So it's a different type of mixture is essentially what that word breaks down to. So homogeneous means, homo means the same. So you have a mixture that looks the same is essentially what that one breaks down to. So with homogeneous, all of the parts in the mixture look the same. So going back to heterogeneous here, we could actually split off your heterogeneous into 2 more subcategories. You have your mechanical mixture where you can see every little bit of, see all the different types of substances in, whatever, type of matter you're looking at. So an example would be like a cookie or pizza. You can see the tomato sauce, you can see the cheese, you can see the dough, you can see all those different pieces. So that would be a type of mechanical mixture. So then the other type is called a suspension. So this is the particles of one substance are held within another in typically a cloudy mixture. All right. So homogeneous mixture, we can also do a subcategory of solutions. So a solution is basically, it's different substances that, that make it up and are not individually visible, sorry. So one thing that I guess is a common question is, well, what's the difference between a homogeneous mixture and a solution? That's a good question. So actually, for the most part, when we're talking about the liquid type of solutions, those are, you could almost always say that they are always going to be homogeneous, or I guess a homogeneous liquid mixture would always be a solution. But there does get to be a little bit more complicated sort of classification when you get into, solids and gases in terms of that type of classification. But We're just going to work with really just the basics of really just mixture versus, or a heterogeneous mixture versus homogeneous. I'm not going to really look at the specifics here because that's too much for us and not really the focus of our unit. Okay, so now moving on over to pure substances. So these are two different types. The first one that would probably make a little more sense to talk about first are the elements. And so when we talk about the elements, if you want to know, well, what is an element, or how would you recognize it as being an element, is you could look at, say, your periodic table. The substance that you're looking at should only be made up of one element or one little type of square on that periodic table. And so if it was a compound, it's made up of two different types of elements. So if you were to look at, say you had a substance and you had a bunch of letters, you didn't know what they meant, but if you were able to match up the different symbols and see that there was two or more different types on that periodic table, then that would be classified as a compound. Okay. So I guess a common example, for compounds would be sodium chloride, which you guys might know more commonly as table salt. So that one is made up of sodium and chlorine to make NaCl. So you have sodium and chlorine, that is two elements making it a compound. Okay. And then yesterday, you guys should have done your physical versus chemical changes. So a physical property describes a characteristic of a substance that can be observed or measured without changing its composition, and composition meaning, what it's made up of. So examples of some physical properties would include the color that it is at that moment. Luster would be its shine, its melting point, the boiling point, and the solubility, or how much of it can be dissolved in water at a certain point without being saturated. So a physical change is basically it's an observable change that can basically be reversed, I guess, is, if I could put that down into the simplest terms there. But it's a change in matter that involves the substance going from one physical state to another. And we're not even just talking about going from liquid to a solid or solid to a gas. It could be like, say you have a piece of paper, maybe I take my notebook here and I rip up a page. I've made it now into two different pieces, but I actually haven't changed what the page is made out of. So that would be a physical change. Crumpling up this notebook would be a physical change because I'm not actually changing what it is, I'm just changing its shape. So same thing as, I guess you even say cracking an egg. At that point, that's still a physical change. You're breaking it open, but it's still the same egg. As soon as you get to cook it, that's a different type of process, because then we're changing, we're really kind of changing what it is. But anyway, so one really important thing here is that a physical change never changes the chemical composition. So you should never have a new substance being formed. Like, say, for example, if I were to take this notebook and I were to put a lighter under it, even if I were I don't know if you guys know, or have noticed this, but sometimes when you burn things, they get like a black outline on there, or like where that flame has been. So that's a carbon buildup, and that's, that in itself is a chemical change, because now we have the addition of, this carbon being formed on here, and it's also a non-reversible process. So we're completely changing it, which would make it a chemical change. Okay, so a chemical property is a characteristic of a substance that describes how it reacts when it changes into a new substance. So the key word there is changing into a new substance. So it's changing in some way that isn't just about its looks or its size, its shape, any of that kind of stuff. It's actually changing who it is, or I guess what it is. I don't want to say who it is, but what it is. So an example would say, I guess would be if it's flammable or not. When you cook something, you can't undo that. So that is a chemical change. And say if it emits heat or light in a reaction. So I guess in terms of emitting light, I think if you were to burn, I think it's pure magnesium, it emits this blinding light. Like, you actually can't look at, I'm pretty sure it's either magnesium or I'll have to maybe double check that one. But I did this a couple of years ago where, I put this piece of metal on a Bunsen burner flame, and it was like such a blinding light.
I think it is magnesium.
I think it is magnesium, yeah. But anyways, yeah, if you actually look directly at it, that's actually, it could actually blind you because that light is so bright. So you would want, like, say if you wanted to look at it, you'd have to look it through, like, say, a lens or like a welder's mask. You would need some form of eye protection because that's how bright it is. It's crazy. And then just talk about the emitting heat. A common example would be like an ice pack or a heat pack. Sometimes when you make with certain types, you might maybe you're breaking it up, and next thing you know, it starts to get hot. Well, that would be an example of a chemical property. Okay, so what's happening there is that those chemicals are mixing, and then they're forming a new substance. And with that chemical reaction, is some heat is being lost in the process. That's actually a really important concept that we study in grade 11 science and a little bit in grade 12. Those are what we call exothermic and endothermic reactions. I think we have a little section later on in the unit to talking about that. They're like big buzzwords, but it is important to know the difference between them. Okay, so our last one. So a chemical reaction is a process where a chemical change occurs. So a new substance is being formed. So general evidence would include color changes, maybe there's an odor, a temperature change, whether or not it's increasing or decreasing. There's a production of light, say if you're burning magnesium, and even the formation of a new solid. So there are some chemical reactions where if you just mix two liquids together, you would get a solid at the bottom that gets formed. It's called a precipitate. You actually get to look at that in the grade 11 science. It's like really cool because you're just like, how does that form? I didn't add any solids. It's awesome. It's great. I love chemistry. So, okay. So essentially, when we're looking at what's the difference between a physical and chemical change, here's an example: is say an ice cube is melting. That's just changing its state, like the state of matter. It's going from a solid to a liquid. It's still H2O. It's still water. So that in itself is not a chemical change. The composition of it hasn't changed. We've just changed how it looks, essentially. Whereas on this hand, we have the fire burning. So you are, you're heating up and burning the log, and you're getting that carbon that's being, piled onto the wood, and the wood itself is burning, and it's releasing some of what it's made out of, and it's irreversible. You can't undo a burn, can't undo a fire. So that's also, I guess, a little. If you want to, as a general rule of thumb, you can't undo a chemical change for the most part. There are a few that you can undo. It would be through a series of chemical reactions to reverse the process, but it's doable. Okay, I guess one last thing is notice here I said general evidence here. That's just because for the most part that would any of these changes would indicate a chemical reaction or a chemical change that's happening, but there's always exceptions to rules, and so there are some cases where you can't, or where you might see this happening, but it wouldn't be considered a chemical reaction.